Good day, students. Welcome to A Plus Model School with Sumeridu, Osun State, Nigeria. Today, we'll be continuing the topic force under basic science, and we'll be treating a subtopic today called calculation of gravitational force. Before we further, let's quickly do a kind of revision of what we studied last week. Last week, we talked about force. Talk about the types of force, the two types of force, which is the contact force and the non-contact force. We also give a kind of mathematical expression of force, which is force is directly proportional to mass and acceleration, and which gives us as force is equal to ma. Also, we talk about magnetic field, we talk about magnetic force, we talk about gravitational force, we talk about electric force as an example of contact and non-contact force. Talk about difference between a gravitational force and magnetic force. We talk about the uses of force. You can refer to the previous video if you are forgetting some of them to watch and rewatch. Now, today we'll be talking about calculation of gravitational force. We know that gravitational force is the force with which the earth pulls all objects towards its center. It is also called force of gravity. I think last week I explained that gravitational force, that when you jump up, you realize that you still come back to the earth's surface. When you throw something up, you realize that that thing will still come back to the earth's surface. If you pick a stone and throw it up, the stone will come back to the earth's surface. There is a force pulling those objects back to the earth's surface, and that force is known as gravitational force. The instrument used for measuring gravitational force is called spring balance. So if you want to measure the gravitational force of an object or of the earth, you use what? Spring balance. Spring balance is the instrument that you use. Today basically we'll be doing calculation. Most of the things we'll be doing today will be gravitational force calculation. And we'll be treating series of examples. Now, let's see how the formulas that we can use to calculate gravitational force. Calculation of gravitational forces. The unit of force, we all know that the unit of force is Newton, and the symbol is represented by capital letter N. The unit of force is being calculated in Newton. The unit was named after Sir Isaac Newton, who first discovered the fact about gravity. So the unit was named after a man that firstly discovered the facts about the law of gravity, and the name of that person is called Sir Isaac Newton. The weight of a body is the force the earth exerts on it. So your weight, or the weight of any object, is the force the earth exerts on that body. That is the way all forces are measured in Newton. On the earth's surface, the universal value of acceleration due to gravity, g, which is always represented by small letter g in bracket, is 9.8 meter per second square, or 10 meter per second square. So all over the earth, this thing cannot change. On the earth, the gravitational value cannot change. Acceleration due to gravity is 9.8 meter per second square, or 10 meter per second square. To calculate gravitational force, the following formula are used. So we want to talk about two major formulas that we use in calculating gravitational force. The first formula is F is equal to mg. F is equal to what? Mg, where F is our force, m is our mass calculated in kilogram, and g is acceleration due to gravity or gravitational force used for calculation of gravitational force. So example 1, let's check out this example. Calculate the gravitational force required to pull down a mango fruit of 10 kg falling with acceleration of 5 meters per second square. Calculate the gravitational force required to pull down a mango fruit of 10 kg falling with acceleration of what? 5 meters per second square. Now let's see how we can solve this. From our formula, we know that F is equal to what? Mg. F is equal to mg, where F is unknown. So we are asked to calculate the gravitational force, which is F, that we are not given in the question. And our m, which is the mass, is 10 kg. And A is given as 5 meter per seconds square. 5 meter per seconds square. Sorry for that. 5 meter per. So, and we know that our formula is what? Our formula is F is equal to ma. You can remember the first formula. Force is directly proportional to mass and acceleration. So we are given the acceleration, we are given the mass. So F is equal to 10, which is the mass, and 5, which is our what? Acceleration, and it gives us 50 Newton. It's as simple as that. It's as simple as that. Now, let's go to another example. Let's go to another example. A mass of 300 grams is acted upon by a force which produces an acceleration of 5 meters per second square. That's acceleration due to gravity, which is dg. Acceleration due to gravity, which is what? G. And that's why it is written as 5 meters per second square. So a mass of 300 grams is acted upon by a force which produces an acceleration of 5 meters per second square. Calculate the force. Now we have to calculate the force, which is the F, and we all know that F is equal to what? Mg, where M is the mass and G is what? As the acceleration due to what? Gravity. And if you notice here, the standard way to measure mass is kilogram, and our mass, the mass that we were given here, is what? Is in gram. That means we have to convert our what? Our gram to what? To kilogram. And how many grams make 1 kilogram? That is 1000 grams. That means to convert our 300 grams to kilogram, we have to divide that 300 by 1000. Note this very well. Make sure that the unit of mass is in the standard form, which is what? In kilogram. Mass is measured in kilogram, but we are given this as what? This mass here in gram. That means we have to convert this gram before we can further with our calculation. We have to first convert this gram to what? To kilogram. And that's why we say 1000 grams give us what? 1 kilogram. And that's why we are divided 300 by 1000, and it gives us 0.3 kg. Now we are good to go to calculate our force. And we all know that our force F is equal to M is equal to mg. F is equal to mg, where M is our mass. We have it as 0.3 kg, and g is acceleration due to gravity, which is 5. 0.3 times 5 will give us 1.5 Newton. I think that too is well taken. That is well taken. Now, let us see. That is the first formula, first calculation. Now, let's check the calculation too. Work done is defined as the product of force and the distance covered by the object. That means work done is equal to force times distance. Work done, which is represented by WD, is equal to F times H, where F is our what? Mg, and work done is our what? Mgh. Now let me take that again. You know that we are substituting the work done, which is the mg, for force. Let's check it out. Work done is equal to force times distance. Our force from the first calculation is what? F is equal to what? Mg. Now, and we know that our work done is equal to what? Force times distance. Now, if we want to input or substitute our F into the formula of work done, we have our work done as what? This substitute of F, which is mass and gram, mass multiplied by acceleration due to gravity, and the what? And the distance. Now, work done is equal to MGA, used for calculation of work done against gravity. It is measured in joules. The first one is the formula to measure the force. Now, the second formula is for the formula to measure work done. Let's continue. Where mass, M is equal to our mass, which is the mass of the object measured in kilogram. I told you that before. G is acceleration due to gravity, measured in meter per second square. And h is equals to height of object measured in meter. Height of object measured in meter. Now, let's take example 3. Example 3. What is the work done by a man who lifts a block of 30 kg through a height of 3 meters? I take that again. What is the work done by a man who lifts a block of 30 kg through a height of 3 meters? And we're given acceleration due to gravity, which is g, is as 10 meters per second square. We're given g. Now let's list the parameters that we were given. We know that our work done is what? Work times force times distance, and our F is what? Mg. Now, our work done is equivalent to what? Is equals to mgh. We are given g, which is acceleration due to gravity, 10 meters per second square. We are given our mass, which is 30 kg, and we are given our height, which is 3 meters. Can you see that this thing has solved itself already? Now, it's just for us to input those parameters into our formula, which indicates work done is equal to 30, which is our what? Which is our mass, times 10, which is acceleration due to gravity, times 3, which is our what? Our height, and it gives us 900 joules. I think that one is well taken too. Now let's move to the example 4. Example 4. If a load of mass 12 kg is raised up to a height of 40 meters, we are given our mass, we are given our height. What is the work done in the process? And we are given our acceleration due to gravity, 10 meters per second. It's as the same thing as the previous example. We are given our work, we are given our mass as 12, we are given our height as 40, and we are given our acceleration due to gravity as what? As 10 meters per second. It's just for us to input it into the formula, which is 12 times 10 times 40, which gives us 4,800 joules. Now let's take this example again, example 5. What is the work done when a force of 50 Newton is applied to throw up a stone across a height of 5 meters? Now note, we're given force and we're given what? The height. Now let's check our first equation that says force is what? Work done is what? Force times distance. We're not going to use this work done is equal to mgh because we are giving our force directly. So we are not going to use this formula, which is work done is equal to mgh. We're going to use our formula, which is work done is equal to force times distance, because our force, which is the mg, has been given. Now let's go back to that example. So we're given our force as 50 Newton and we're given our height as 5 meters. And we know that our work done is equal to force times distance. And since F is equal to 50 Newton, distance is equal to 5 meters. Our work done is what? Force times h, which is the distance or the height. And we have it as 50 times 5, which gives us 250 joules. Now, after taking all this example, for you to understand very well, that's why I give you like 5 good examples. So either way the question might come, you will find it easy to solve. Now, you can do this on your own. Let's see how you go with it. You can do this on your own to use it to evaluate yourself. Maybe you really understand the topic. If you don't get the right answer here, you have to go back, and I will be adding this to your assignment that you have to snap through your WhatsApp page and send it to my personal WhatsApp number. If you lift an object from the distance of the ground, you do work in opposing the gravity. Suppose you lift an object of mass 2 kg from the ground to the height of 2 meters. What is the work done in lifting the object? And we are given G as our what? As our 9.8 meters, as 9.8 as acceleration due to gravity, as 9.8 meters per second square. Here, if you look closely, here we're given the mass, we're given the height, and we're given to what? We are given the acceleration due to gravity. Which formula are we going to use here? We're given the mass, we're given the height, we are given to what? The acceleration due to gravity. The formula we're going to use here to calculate our work done is what? I think you should be answering that question to yourself. I don't want to answer that for you. Check the previous so that you can use it to evaluate yourself if you can get it right. Now, assignment. I want you to read up. This is our next topic. I want you to explain the concept of friction. What do you know by friction? You snap it and send it to my WhatsApp page on Saturday, before Saturday. You define balance and unbalanced forces. I'm giving you this so that you can read ahead. So try and check your textbooks, or you can browse on your phone, read anything you can lay your hands upon on friction, concept of friction, and balance and unbalanced forces. So till we meet next class, thank you for your class, for your rapt attention, and by next week we'll meet again and we'll talk about friction. My name is Taylor Samson Additional. I've been your tutor. Good day.